You have 3 seconds before the atmosphere kills you. Not from the heat. Not from the pressure. From the glass, traveling sideways at 2 kilometers per second, shredding everything it touches. In the next 7 minutes, you're going to survive a simulated descent into HD 189733b, the most violent planet ever confirmed in the known universe. By the end, you'll understand exactly what's down there, why it exists, and why it permanently changed how scientists think about alien worlds. From a distance, HD 189733b looks almost peaceful. Almost familiar. It's roughly the same deep blue as Earth when viewed from space, that brilliant, calming azure that makes our planet look alive. But the similarity ends there, completely and violently. This world is located 63 light-years from where you're sitting right now, in the constellation Vulpecula. It's a gas giant, slightly larger than Jupiter, locked in an orbit so close to its host star that a full year there lasts just 53 hours. 53 hours. That proximity means the day side of this planet bakes at over 1000 degrees Celsius. Not the surface of a volcano. Not the inside of a furnace. We're talking temperatures that vaporize rock. But here's the thing that makes HD 189733 be genuinely different from every other hot Jupiter we've found: it's the atmosphere. That gorgeous blue color? It has nothing to do with water or oxygen. It comes from silicate particles, tiny fragments of vaporized rock and glass suspended in the upper atmosphere, scattering blue light exactly the way our sky does. A perfect illusion of serenity. A sky that looks like home, made entirely of condensed, swirling glass. Let's run the simulation. You're approaching in a hypothetical probe. Instruments active. You cross the upper thermosphere at roughly 80,000 kilometers above the cloud layer. Temperature readings climb immediately. 100 degrees. 400. 700. The hull begins to glow. This is normal. This you can engineer around. Then the wind sensors activate, and the numbers don't make sense. Winds on HD 189733b blow at speeds exceeding 8,000 km per hour. That's roughly 6 times the speed of sound on Earth. The jet stream here doesn't flow gently around the planet, it screams. It blasts heat from the day side to the night side in a relentless, planet-spanning hurricane that never stops, never weakens, never sleeps. Meteorologists on Earth study storms that last a week. The storm on this planet has lasted longer than human civilization has existed. You are now inside that storm. And it is carrying something with it. Here's what those winds are carrying. At the extreme temperatures near HD 189733b's dayside, silicate minerals, the same basic material as the sand on any beach on Earth, are vaporized completely. They rise into the upper atmosphere as gas. Then, as that gas gets blasted toward the cooler nightside by those 8,000 km/h winds, it cools just enough to condense. To become droplets. Droplets of glass. Molten, superheated, razor-edged silicate glass. Falling sideways. Not down. Sideways. The winds are so ferocious that precipitation on this planet doesn't fall toward the surface, it's flung horizontally across the atmosphere at nearly 2 kilometers per second. Your probe's external cameras would last approximately 4 seconds before the glass sandblasts them into nothing. The hull itself, even reinforced titanium, would be etched, then pitted, then penetrated. But before we get to what this planet revealed about the universe, you need to understand something even stranger about where this glass actually goes. The glass doesn't accumulate. It doesn't build up dunes on some hellish surface below. The silicate droplets get carried by the wind, they travel from the night side back toward the day side, and the temperatures climb again, and they vaporize. Again. The entire planet runs a continuous loop. Rock becomes gas, gas becomes glass, glass becomes projectile, projectile becomes gas again. A geological cycle running at hurricane speed, every hour, for billions of years. There is no surface calm. There is no eye of the storm. There is no safe altitude. HD 189733b is not a place with dangerous weather. HD 189733b is the weather. In 2013, astronomers using the Hubble Space Telescope made a confirmation that stopped the scientific community cold. They detected the atmospheric composition of HD 189733b directly, the first time silicate particles had ever been confirmed in an exoplanet atmosphere through reflected light analysis. It was the first real proof that alien atmospheres could behave in ways that had seemed impossible just a decade earlier. What it revealed wasn't just a strange planet. It was a proof of concept. If silicate rain could exist here, the range of possible atmospheric chemistry across the universe expanded overnight. Worlds with iron rain. Worlds with titanium clouds. Worlds raining liquid rubies and sapphires. The cosmos had just gotten infinitely stranger, and infinitely more real. You survived the simulation. Barely. HD 189733b is real, it is confirmed, and it is 63 light-years away, so far that the light leaving it right now won't reach your eyes for 63 years. But we know what's there. Glass rain. Supersonic winds. A planet that is simultaneously gorgeous and unsurvivable. A blue marble, with teeth. If this broke your brain a little, subscribe. We drop one of these every week. And next time, we're going to a place even closer to home. A moon in our own solar system where the ocean is buried under miles of ice, and something down there might actually be alive.